so I created these problems so that we can, get a feel for the type of problems that you can encounter when it comes to calculating the pH at any point in a titration experiment. So the question here says we dissolve 0.100 mole of hydrochloric acid in sufficient water to make it 1.00 liters and then titrate it with a 0.100 m sodium hydroxide solution. All right. So the first question is, what is the pH before any of the sodium hydroxide is added? So basically that means that we need the concentration of HCl, which is very simple. In fact, let me go to my sketch application here. So therefore it's very simple actually. The concentration of HCl is going to be equal to 0.100 mole over 1.00 liter, and that gives the answer of 0.100 m. And because we know that hydrochloric acid is a strong acid, this would be equal to the concentration of H+. So all we have to do is find the pH. pH is equal to minus log of the concentration of H+, which is 0.100 m, and that would be equal to 1.000, and that would be the pH of the solution before any sodium hydroxide is added to it. So that's relatively simple. That's the easy part of this exercise. So because I know I need space for the next part, I have to erase all of this here. Okay, so let me go back to the questions. The next question says, what is the pH when 20 mils of sodium hydroxide is added to it? So in this case, we have to do some calculations, firstly, of the moles of sodium hydroxide and the moles of hydrochloric acid. So let's do that here. Moles of sodium hydroxide would be equal to the volume, which is 20.00 mils of sodium hydroxide added, but we have to convert that to liters. So we're going to have 1 liter over 1,000 mils, and that would be multiplied by the molarity, which is 0.100 mole for every 1 liter. And the reason why I set this up so that you can see how the units will cancel out. So when I did this calculation, the answer I got is 2.00 times 10 to the minus 3 moles. So that would be the moles of sodium hydroxide. And as far as the moles of HCl is concerned, that was given earlier. That was given as being equal to 0.100 moles, all right? So no calculation was needed to do that part. All right, so the next part is I'm going to write down the balanced equation for the reaction. And then I'm going to do an ice table, initial change and end of reaction. It won't be equilibrium because remember all acid-base reactions go to completion, right? So that's why we have a one directional arrow indicating that we don't have the two arrows going back and forth. All right, so far we have the moles of hydrochloric acid, which is 0.100, and the moles of sodium hydroxide, which is 2.00 times 10 to the minus 3. We have none of the sodium chloride, and we don't need to concern ourselves with water. The change, okay, so because this reaction goes to completion, that means that the limiting reactant, which is obviously the sodium hydroxide, will be totally used up. So as far as the sodium hydroxide is concerned, the change is minus 2.00 times 10 to the minus 3. And here is going to be the same thing because of the 1-to-1 ratio between those two. And here is going to be plus because, again, the 1-to-1 ratio, in addition to the fact that sodium chloride is being produced. So at the end of this reaction, you're going to have none of that. Here, you're going to have, according to my calculations, 0.098 moles. And here you're going to have 2.00 times 10 to the minus 3. Now, sodium chloride is the product of a strong base and a strong acid. So therefore, this would be neutral. and therefore will have no effect on the pH, all right? However, and there's no sodium hydroxide present, so therefore the pH will only be affected by the presence of the hydrochloric acid. So therefore pH is equal to minus log, well, before we do that, we need a concentration. The concentration of HCl is equal to 0.098 moles divided by the volume. Now, what's the volume? The total volume would be the 1.00 liters of the hydrochloric acid plus the 20 mils of the sodium hydroxide, which is the same thing as 0.0200, one more zero, and then liters, right? So that's a total volume. So when you add this up, this gives you a total of 1.02 liters. So that would go here in order for you to calculate the volume. So when you do that calculation, according to my numbers, the answer becomes 0.96 m, which would be equal to the concentration of hydronium or H plus ions at the time. And therefore pH would be equal to minus log of 0.096, which is equal to 1.01. So that would be the pH at that point, all right? So this is the pH before we get to the equivalence point. So the next question is asking for the pH at the equivalence point. So I'm going to deal with that in the next